Just some context for those of you that are not familiar with Broadcaster. It's a protocol initially developed by the Arbitrum team, the Off-chain Labs team, and it's meant to be a fully trustless message passing system. So uh, inside OIF, we are using this for as an oracle. It's relatively slow because it needs for settlements to be executed. So in a lot of cases, this means over 7 days of confirmation for the oracle to be viable. But um, we are obviously depending on the network, that time can be smaller, and as you know, the time of rollups hopefully will be reduced in the mid to long term. So this was initially developed by Oxen Labs by the Arbitrum Foundation, yeah, 2035. And we from Open Zeppelin took over the final development and polishing of it a couple of months ago. The initial core contracts of the protocol have been audited, and I think the audit report will be public this week for sure, so we can share that when it's ready. The architecture of the system basically requires a core contract, a broadcaster contract on each network, and then for each architecture of the networks to have a specific prover. So we've also developed provers for 6 networks or 6 architectures: Arbitrum, Optimism, Linea, CK-Sync, Taiko, and Scroll. Those provers are ending the development cycle right now and are actively being tested in testnets. We'll probably do an audit in February, and after that will be deployed to mainnets. So this is a fully decentralized protocol. Anyone will be able to deploy their own contracts and verify their own messages. Open Zeppelin will deploy the reference contracts and provers to be used. But again, any particular team that may be interested in running their own set of contracts for whatever reason will be able to do so. Depending on the network, these messages are broadcasted and passed along automatically. Some networks basically put the status or the information from the layer 1 into the layer 2 automatically, while others need a pusher. That pusher will also be available, and guides on how to transmit the pusher will be available for the public. So the broadcaster protocol is likely gonna see like real use cases in the first quarter of the year. If anyone is interested in tinkering around, playing around, experimenting with it, right now it's in a decent status so that we can get started on testing in testnets. So if you're building on it or you're interested in exploring, breaking, auditing, testing, feel free to reach out to me through Josh or directly in Telegram, and we are happy to collaborate on that. Can you send some info on the testnet? I will now share the existing deployments, but there is no um, kind of app to interact with these things. It's meant as an oracle, so anyone interested in interacting with the contracts will have to generate their own proofs, and it's not a lightweight protocol. It's pretty heavy. It's the drawbacks that comes with real decentralization and real trustlessness. Any questions?
Cool. Thank you, Pepe. Appreciate the last minute jumping in. Excited to have
Yeah,
this. And
good.
yeah, thanks to Arbitrum and everyone who's been a part of this. Excited to have it as part of the OIF as the broadcaster oracle. Cool. So maybe we can switch back. I think we'll have some more OIF updates later in the call, but maybe we can switch back over to you, Noah, to share some presentation I think you have prepared on the ZK Sync Interop.
Sounds good. Glad to share.
Oh,
I just need to request the sharing thing.
yeah, now you're
Cool.
good.
Thanks. Do I not have this enabled? Okay. I'm gonna have to quit and reopen Zoom.
You
Okay.
probably
I
don't
had to-
need to. Just try. If it's macOS, it's a fake warning. Just try.
Okay. Yeah, that worked.
Forrest always comes through with that tip.
It's so annoying. Like they've had this for years.
Yeah, it is a bit silly. Yeah, excited to be presenting today. Today, I'll be talking about scaling Ethereum's liquidity with L1 interop that is provided by ZK Stack. Our goal with this is to solve DeFi's structural cold start problem. And my background is I'm the director of Interop on the product side at Matter Labs. So the current issue, and we see this with every single new chain, whether it's an L2 or L1, we saw with Parachain, we saw with Plasma, we've seen it with all of the different L2s, is every chain starts from zero currently. Every single application that you want on that chain needs to redeploy. We need to rebuild liquidity. They run these massive liquidity mining campaigns where they spend tens, if not hundreds of millions of dollars to essentially subsidize DeFi liquidity. And you end up having very, very, very mercenary capital that comes onto your blockchain and gives you the appearance that your blockchain is succeeding. But when those incentives dry off, Ethereum still holds the majority of real durable DeFi liquidity that stays for cycles, between cycles, essentially. So the structural cold start problem repeats across every single new ecosystem, and it's something we notice in our ecosystem as well as other ecosystems that we're launching as well. So for the longest time, Ethereum has used L2s to scale its performance, but for the first time, L2s can now scale Ethereum liquidity via ZK Stack. So the reason why we're able to do this, and I'll go more into the tech part of it later, is we recently came out with the ZK Sync Atlas upgrade, which is our new upgrade that gives us EVM equivalents 15,000 transactions per second, 1 second ZK proving time, and our proving costs have dropped dramatically as well. The second thing we recently came out with, and this has been in development for a while as well, alongside the Atlas upgrade, is something called ZK Sync Private IAMs. So it's the first blockchain platform to essentially unite the verifiability and interoperability that we've come to love of public chains with the control, privacy, and compliance needs for institutions to actually operate on chain. So our solution essentially marries Ethereum with ZK proofs by combining the most neutral global settlement layer with the strongest guarantees and the largest network effects with ZK proofs to allow institutions to operate compliantly while still having interoperability and allowing for high throughput at a low cost. So what L1 interop is the first thing that we demoed a couple of weeks ago was users on any ZK chain. It can now deposit into Aave on Ethereum, borrow assets like Go or USDC or any other asset on Aave, and access Ethereum DeFi without switching networks. They maintain one wallet, one identity, and one streamlined user experience. And private IAMs allow institutions, when they're operating their own private execution environment, to access these markets as well. So instead of each individual institution needing to have a forked instance of Aave, Morpho, or any of these other large DeFi protocols, they can now tap into Ethereum DeFi from their L2, allowing them to do things that were previously not possible, because typically institutions do not want to operate on public chains showing off everything that they're doing. But if you can allow them to operate privately for the things that need to remain private essentially, but actually still tap into L1 DeFi, we've seen that they are very excited to use that primitive overall. And we think that's how you bring institutions back to DeFi essentially. So the way it works at a high level is a user signs 2 transactions on the L2. Transaction 1 is essentially having your funds get withdrawn to a cryptographically bound aliased account on the L1. And the second transaction is an interop bundle that contains a list of L1 DeFi actions. Optionally, you can also bridge tokens back to the L2 automatically as well. So the way it works, and this diagram just essentially goes over exactly what I said before, is to the user, they just fund their alias account. In this case, with ETH, they execute the action, which is depositing into Aave on L1, getting a real position. They receive the A token in that account on L1, and then they can view a unified balance. So the user, it's like they're never leaving home. And well, this work still happens on Ethereum, so there's no commingling of user funds as well, which is crucial for systems like this to scale. So the reason why this is now possible is due to us having much faster ZK proof and generation and settlement than in the past. So airbender proofs typically can be generated in around 1 second. Oh, are there comments? Oh, got it. Sorry, saw chat. And withdrawals can finalize on L1 in minutes. We also have a multi-implementation sequencer which hardens against bugs and attacks. And the alias account is a deterministic L1 address mapped to a user's L2 account. And it doesn't require new keys, and it doesn't require another custodian on top. And it's very easy to support as well. And the Interop transaction bundles can essentially contain arbitrary actions. So in this demo we did of Aave, it would be relatively straightforward to do it with Morpho, Uniswap, Pendle, anything else you want to do on Ethereum. It preserves the full Ethereum building, and the bundle is executed via the alias account. And it's a really seamless UX. So these borrowed tokens can be bridged to the L2, and the user never has to leave the chain, never has to handle L1 gas or accounts manually. And with Privatiums, this allows institutions to get private access to lending markets, liquidity pools, yield markets, usage of existing protocols, not forks, internal workflows stay private while the market actions settle on Ethereum. They can also do things such as optimizing collateral for treasury and credit and funding operations, moving funds between L2 and L1 in minutes, and accessing intraday liquidity and hedging capabilities, private operations on L2, market interactions on L1. And the thing that I'm really excited about as well is really around the trading use cases and more advanced use cases, I would say, where you can essentially run all of your more computationally expensive logic on the L2, such like a matching engine, credit systems, like order books, things such as that on the L2, but still access collateral on ETH L1. So that allows for essentially, there's a structural mismatch right now between ETH L1 liquidity costs and ETH L2. We actually we spoke to all of the different teams that run the liquidity farming campaigns and run the different vault systems. And what we realized is if you look at Morpho and Aave on ETH L1, their users are fine receiving a lower rate on those protocols than they are if they're on an L2. So if you are an L2 or an Alta L1, you always have to pay greater than the Aave or Morpho rate that is on Ethereum because there's the there's the extra risk of me moving capital to your chain, and there's quite a few LPs or liquidity providers that don't want to move to those chains. So due to this, you can actually get capital for cheaper. So this offers a structural advantage for L2s that tap into the system because they're able to essentially get capital that would be fine at a lower rate compared to every other alt chain system or other L2. And long term, we believe this allows Ethereum to really become the capital hub. ZK chains and Privatiums allow for sovereign and sometimes private compute. Ethereum gets the shared settlement and liquidity base, and usually get the best of both worlds, having institutional privacy, public market depth, and a unified ecosystem rather than fragmented islands. And frequently asked questions as well. Today, a separate account finalizes withdrawals and executes bundles, but soon applications will be able to charge L1 gas on L2. Supporting new protocols is very straightforward. It's generic, so it's very quick to add them. Protocol teams can also do this themselves. If you're a protocol team interested in this, feel free to reach out. We'd be glad to support. And it only costs a couple of dollars per transaction. The main delay is Ethereum finality and the final, and essentially the frequency of settlement as well. And one transaction is coming soon. That will likely be done with an account abstraction system. So yeah, that's everything. Thanks so much for having me.
Questions for Noah? Maybe one question to start off. You mentioned it here a little bit, but I guess, yeah. Can you share more around how fast this, like, it sounds like this is sort of on the order of minutes rather than seconds for
Yep.
most flows today, bottlenecked by the L1. Will that in practice prevent a lot of the usefulness if this is minutes? Like, how do you think about this and users' willingness to wait minutes for certain flows?
Yeah, so on that side, the primary customer for this is actually institutions. The majority of zk Sync L2s that are coming out that are new L2s are using our Privatium stack. So they're institutions that are managing collateral. So for them, when we're able to tell them, okay, you can now manage your lending workflows and it's going to take 10 minutes rather than them having to call their lawyer, enter in a new counterparty agreement and go through all of the headache. Like currently lending in traditional markets, it just takes a lot longer. It's not as programmatic. So the fact that they can do this for any asset at any time and set this up in a matter of minutes is like a massive change, and much faster. So for crypto people, it's obviously something where it's like it's not as fast as they're used to. But I think over time, the bet that we're making is the majority of new capital and new users coming into blockchain systems won't necessarily be crypto native, and it'll also be used more and more so in a backend like capacity. So if it's a backend like capacity, you don't necessarily mind as much about things like this because it's so much faster than your current system.
Got it.
Yep.
Chris, you have a
Ernst?
question?
On the 1 second latency within the cluster, what makes it such that I guess it's like a ZK stack L2 or L3 getting like a proof done for, I guess, some significant gas? Why is it so much faster than actually proving to the L1 in terms of prover time?
Yeah,
Like, is
so the way
this
that
due to like hashing or like ZK friendliness? Where is this big discrepancy from?
Yeah, so the reason why is there you can obviously sell to the L1 more frequently, as well over time. There, what the gateway is doing is essentially aggregating the proofs. So when you need to aggregate proofs across multiple chains, that's always going to take a while. And there's also within our system, we essentially have two different types of proofs. We have the Fry proofs, which are very fast, and then we have the Snark proof, which is the proof that gets verified on L1. The snarkification process takes a couple of minutes currently. So that obviously causes delays for things. Hope that
Gotcha.
kind of
Thank
answers
you.
it.
A couple of questions in the chat, but maybe Lumi, do you want to read out your question?
Yeah, so the chains are settling to ZK Gateway as pseudo L3s. So you basically the chain operator or the user needs to wait for ZK Gateway to settle onto L1 before any actions can be executed, right?
Yeah.
How frequently does ZK Gateway settle currently?
It's for us right now, ZK Gateway will be settling quite frequently.
Isn't
So
there still a 3-hour withdrawal period? Like artificial
once
delay?
we had, now that we have the multiple implementation of sequencers, we don't have the 3-hour withdrawal window delay anymore.
Just to quickly interrupt here, I think Lumi knows the ERA implementation more, which has this finalized withdrawal, but the new ZK Sync gateway will be on the Atlas upgrade, so it's not really relevant here.
Thanks, Kalman. Anjan? I believe I pronounced that.
Hey, yeah, that's right. I did not follow much of the development of the Previdium, but can you give me a thought, maybe a gist of how does it achieve the privacy guarantees, or what are the things that it offers, and how does it do that?
Yeah, so for Privatiums has a role-based access control system on top of it. So it gives you privacy in the same way that you would have privacy in like a traditional database. So you're able to essentially choose which users see which different smart contracts, and you can do different roles for different users. You can even allow for different applications to see different smart contracts as well operating on the Privatium. It really allows for a much more granular level of control for the chain operator that previously wasn't available. Hope that helps.
But does it use anyhow stealth addresses for transaction unlinkability, maybe?
Privatium is an enterprise product, so it's not necessarily doing privacy like Zcash. It's more privacy like a institutional level privacy. So privacy like Snapchat or email.
Okay, makes sense. Thank you.
Yeah, no problem.
So that means you guys are not using hiding, like you are not using ZK snarks, you're just using snarks or stocks, right? For
So there's
Prividium.
for Prividium in particular, it is a ZK rollup. It's a ZK rollup that is a Palladium, and the data is held off chain. And then we have a role-based access control system to essentially allow enterprises to choose who can see which things on their chain, and they can define user groups, different roles, different even contract level permissioning. So that's the primary use case for it. It's not necessarily designed to be used like a mixer or anything like that.
Gotcha. So it means in particular you are posting a normal snark to L1, which leaks information about what happened, but you assume because it's like in practice quite little that it's private enough. And you basically restrict access on RPC level.
It does not leak information to what happened. The way that our system works is you are not leaking information about what happened on essentially the execution of the L2 itself.
Okay, so it's a different prover than the Airbender prover?
It is the Airbender prover. The way that we have designed the system is any personal identifying information for the different institutions that are operating their own Prividium is kept private and kept on their own servers.
Okay, so maybe this is just a theoretical nuance then. So is it adequate to say the RPC is the gateway to basically authorizing this user to access this data and another user to access another data?
Yeah, the RPC for the Prividium is where all of the rules are set.
Makes sense.
Cool.
We're getting a little bit low on time. Maybe I can read. There's one question from Frangio in the chat. I'll read it. How many of these Prividiums are there in prod currently or coming soon?
So we currently have one live already with a company called Memento that's operating it for Deutsche Bank. And we have other major Prividium announcements will be coming out in Q1. So we have a lot more that are on the way. So yeah, most of them are going live in Q1. We have a few they came out that were recently announced, such as Elnet that's launching on Prividium and Latam. We have a lot more that are essentially coming in Q1 and Q2. Due to the nature of most of these customers, we can't say them publicly until they're announced, just due to NDAs.
Got it. Thank you, Noah. This was great.
Thanks for having me.
Appreciate you coming on. Cool. Next up on the agenda, OIF, some more updates, I think, on that side of things. And I will kick it over to Orca if you're available.
Hey, yeah, sure. How much time is there, just for context, if you said we were a bit behind?
I think we can, yeah. We got at least 10 minutes, let's say, here for, yeah.
Cool. Let me probably will not reach that. I guess I'm going to run through a couple of things. Can you see the screen? Great.
Yep.
Okay, great. So I guess just a few things OIF related, and then one Interop address thing just to make folks aware. So first is asset discovery. So Interop providers invariably have an API for their chain or asset support. But this wasn't part of the OIF specs, sort of API specs currently, which just cover getting quotes and sending orders. So we've added this to the OIF specs, and it'd just be good to get feedback if you're a person who either has such an API or like has opinions. So it's pretty simple. It's based on the solver, the existing OIF solver implementation, just as a starting point. But there's probably room for a bit of bike shedding, but also just be interested in people see it because you see different approaches. Some people have a separate endpoint for chains and for tokens, and some support routes, specific routes. So making people aware of this and soliciting feedback. Similarly, we're at Wonderland, we're working on the cross-chain module of the Interop SDK. We're trying it out on different OIF compliant Interop solutions. with our with a sort of OIF provider, which basically implements the spec. We've found some areas where existing providers are not aligned with the OIF specs. So I think that's one where we're talking to Open Zeppelin about the sovereign aggregator, and we've also been trying out Li-Fi. We'll be reaching out to teams to check if things are expected, unexpected in terms of any digression from the spec. But if there are other folks who are running OIF compliant solvers or endpoints, we'd love to take them for a spin. So as I said, we're aware of Open Zeppelin and Li-Fi, but let us know if there are others that we can be testing with. I'll keep rolling. In the same vein, in the SDK, one thing we're looking at is quote validation. So this is when you're actually interacting with an API, you'll send maybe an intent and you'll get back a quote and something to sign. Obviously, there's a risk there if it's a server you don't trust, because they could give you back anything to sign. So one thing we're looking at adding to the SDK is obviously sort of client-side validation. So if anyone else is thinking about those kind of things, that's passing whether it's a transaction to make on-chain, if it's a user submitted intent, or if it's a someone to thing to sign, making sure that you're actually signing something that you're happy with that actually meets your initial requirements. We'd be interested to talk to any other teams who've thought about that problem of not just trusting what you get back from an API. And then lastly, 7930. So this is in the slightly different thread, but related. So interoperable addresses. This is the spec which has undergone a lot of revision over the last couple of months, thanks to I think the Unruggable folks who are on the call, who've been collaborating with us on this. So we'd love to hear any feedback if someone read the spec a little while ago and thought it wasn't that clear. Like hopefully it's better now. I think I did just want to draw this group's attention to one thing which is a bit under discussion. So currently 7930 defines both the interoperable address, which is binary machine readable, would look something like this if you were to print it out. And it also defines interoperable names. That's a sort of complementary string which is parsable by humans. I think there's some debate over whether it's readable by humans or not. So here you've got the address, you've got the separators, and then you've got CIP identifiers and a checksum. And then the other interoperable address, ERC, makes them more human readable by introducing ENS support for addresses and chains. And the point of discussion has been whether having both the address and the name in the same ERC is confusing, or potentially confusing for people who might be looking to either use the standard in other ERCs or just implement things. So again, welcome folks. We'll, I guess, be posting on the forum to notify of the recent changes to get any eyes of people who haven't looked at the spec for a while. But would also, yeah, we're thinking about this, or we've been discussing this specific question. Just be good to see if there are any other opinions out there. And I'll stop sharing and look at the chat if there is any chat. And yes, thanks folks for sharing the ERCs. Frangio.
Can you clarify what's being discussed? So the interoperable names are currently in 7930, and you are discussing whether to remove those and move them elsewhere?
Yes, I think, I don't know if Prem is on the call. I think he is. But I think, yeah, this was based on some of his feedback, which was just saying that having the names and the addresses in the same thing then made it a bit unclear what a 7930 address meant, which of those sort of formats it meant. And so I think there are obviously like a couple potential approaches from where we are today. But yeah, maybe Prem, if you want to outline your case.
Can you hear me?
I can.
Okay, good. Yes. So I think this discussion started. I think Teddy had posted something about clarifying the difference between the interoperable address and the interoperable names. And my opinion was that it should be very clear when someone says 7930 address, what they mean. And I noticed in the 8092 spec that Steve Katzman of base names was going to a particularly high degree of intention to specify the binary representation versus the interoperable name version. And I just thought this would be a burden going forward for people who are having to specify 7930 addresses. And it should be a very easy interpretation. So if we move the interoperable names portion to 7828, then it would be clear that we have a binary specification and then a more human readable specification in the 7828.
Does that make sense, Franjo? Anyone else? I think it's maybe hard to get up to speed with all of this on a call. Maybe we can take the discussion to the Telegram group, but yeah. Okay. Anything else
Perfect.
to touch on this topic? Orca, Prem, anyone else?
I think that was it. There are a few links which I'll share in the channel if anyone does want to follow up. As I said, that was mostly a call for input. And yeah, as Teddy says, the forum I think probably is the best place going forward. And as you say, we're trying to obviously, as with all these kind of things, balance speed, but obviously also quality. So we just want to make sure we get that right.
Yeah. Thanks, Teddy, for flagging it. Take the discussion to the forum, and we'll try to balance getting things right with endless discussion threads. And yeah, thanks again to Unruggable, Wonderland, Orca, everyone for jumping in. Excited to have these released to the public very soon. Interoperable addresses. Cool. Okay, so I think we got through what was scheduled on the agenda. One thing that I added is just an opportunity for any open discussion. I'm not sure exactly maybe where this will go, but for anyone to sort of share their thoughts. I know there's a few folks here who have been thinking quite a bit about this, the topic of full synchronous composability in Ethereum, sort of the value, the urgency, the priority. How should we be thinking about this as an ecosystem? The question of async interop, and does this actually get us most of what we need? Sort of a cost benefit question here for the ecosystem. Yeah, we of course won't settle this in 20 minutes here, but it'd be great to maybe just use this as a opportunity for people to share their thoughts, and maybe we can try to move this question into a more productive place together. And anyone want to jump in? I know Alan, you shared I think a really great ETH research piece on this not too long ago. I encourage folks to read that. Maybe if you want to drop the link, or I can find a link to that. Maybe if you want to start with like a quick, I don't know if you're able to sort of like summarize it in a minute or two, but maybe just sort of, or sharing whatever you want in terms of your perspective on why you're bullish us prior to us as an ecosystem putting much more resources into synchronous composability.
Hi, everyone. Josh, thank you for having me. I would love to kind of open up the discussion. So I've been thinking a lot about Interop for the past 6 or 8 months. And obviously, we've came along, a great deal of work has been done. Intense Today's is the kind of the premier framework. But I would maybe kind of suggest thinking about 2 things. One is like everything with Ethereum, we kind of going from the philosophical to the practical or the engineering, right? So I would start with the philosophical question. What is exactly Ethereum? Is it Ethereum DL1? Is it Ethereum, the greater Ethereum, as I call it, but basically Ethereum and all of its rollups, and so on. And I think that the way I look at it is...
I'm just going to leave, but sorry.
I think you.
Yeah. Okay. So the way I look at it is the real power behind Ethereum is its network effects, users, dApps, and really the flexibility of what it can do. And so I would suggest that, or at least I view it as Ethereum or the greater Ethereum, meaning that Ethereum DL1 and all of its rollups should feel like one big execution environment. Meaning that if I'm a user or if I'm a developer, I shouldn't be experiencing moving between domains as if they are completely separate chains. And I think today it's very much the case. We've gotten really good at moving value between chains, not necessarily just even within Ethereum, between Ethereum and even other chains as well, Solana and so on. We gotten really good at that, but also we got pretty worse at fragmentation. I think that's a kind of a core question I've been battling with. And I don't think intents alone or really fast asynchronous message passing can solve. If the goal, at least for me, is kind of this one unified execution environment where me as a developer, I can do arbitrary read and writes, bidirectional arbitrary read and writes between different rollups and Ethereum and rollups, and have it in a stateful way. I don't think asynchronous message passing or intents bring us to that point. And so that's what kind of piqued my interest in synchronous composability. Maybe we can follow up with that kind of what it can enable us and so on. But I would kind of want to suggest that a lot of has been done the past 2 years with synchronous composability. So a lot of the kind of notions of what it is kind of actually changed the past 2 years, and more specifically the past 12 months. Both research on Interop, synchronous composability Interop has gotten really good, and also ZK VMs got into a point where it's actually feasible to do, I think, in a way that is not intrusive, and actually from an engineering point of view and a product point of view makes sense. And so that's kind of how I look at it. Yeah, I mean,
what do you think, Alan, about this sort of the fundamental tensions that Mark from Optimism brought up in the chat around this idea of synchronous composability, the challenge around extending that across governance boundaries?
Yeah. So I think that a lot has been done in that area. So it used to be the case that synchronous composability was imagined or thought of as shared sequencing. In that context, I do believe this is not feasible and not something that we can bring to market. Rollups need independent sequencers for many reasons. But research and work has been done to actually not require that anymore. So if you guys are familiar with the Fabric team and their scope framework that they released, I think around 3 or 4 months ago, which is really, really cool. Our work at Compose and others, we don't talk about shared sequencing anymore. Everyone has different approaches, but I do think there's a feasible way forward with synchronous composability, which does not require compromising on who runs the sequencer, meaning that rollups can have independent sequencers. Furthermore, rollups and sequencers of those rollups can actually decide how they manage interop in that sense. So, for example, if you don't want to interop with another chain, you can make that decision, and it's simple config on your sequencer. And so those things came a really long way, and I think that kind of puts it in a really good place from an engineering and feasibility point of view to actually be adopted, because it's much more lightweight than it used to be in terms of kind of the infrastructure to acquire and so on.
I have other questions, but does someone else want to jump in here, either on either side of the debate? Anyone from, there's a few folks from Gnosis team, I don't know, Sebastian or Frederick, if.
Yeah, so hi, I'm Friederike. I'm one of the founders of Gnosis. I'm here for the first time, so good to see you all. Yes, we were invited to this group and this call because we've recently started looking into, more seriously started looking into synchronous composability with real-time proving as a core tenet of that. I 100% agree with Alon that synchronous composability is where it's at. So kind of I mean, we are big on intents. We kind of build cow, and so kind of like it's not like I don't want to dunk on that, but if you want to if you want the wider Ethereum ecosystem to feel like one ecosystem and not a fragmented federation of different ecosystems, for instance, if you want to be able to have an identity on, say, a very privacy respecting network and interact with dApps on other networks without kind of porting all of that over. I think kind of being able to compose synchronously, so kind of being able to call a smart contract on network A from network B, and vice versa, is absolutely key. And I think there are different ways of actually getting there. The one that we, together with Jordi from the Zisk team, kind of developed, functions somewhat differently from Alon's, but kind of ultimately, if we end up getting one of these solutions, I think the ecosystem will be so much better off, because it's not just about shared liquidity. Kind of, yeah, we can, I mean, with kind of intense frameworks, you can move tokens over fairly quickly. You still need liquidity providers and so on, but I mean, it works. Kind of Kausop also works, but for more involved business logic that goes beyond sending tokens, you need synchronous composability.
Can you give an example for what use cases or what flows you would have in mind that would actually require synchrony rather than just composability?
Well, everything where kind of you have where you want one protocol to interact with another protocol and they're not on the same rollup, right? So for instance, if I have say Aztec ID on Aztec, and I want to do something on, say, ZK on ZK Sync, then kind of I need to be able to kind of prove my identity for certain use cases, kind of in an atomic transaction in order to do something. And this is only possible if you have synchronicity.
But
why do you care about this being atomic? Why not just send a message via the canonical bridge that takes, let's say, 1 hour to finalize on the L1 and then read it from the second rollup within 16 minutes?
But that's a terrible user experience. Kind of
16 minutes is forever.
Yeah, that's a terrible user experience. So if you just want to do something on another network that requires proving your identity, you don't want to wait for 60 minutes for that. I mean, that's yeah. I mean, currently people have to do this, and I think kind of the one argument that I hear against it is that kind of current dApps do not require this, but current dApps do not require this because it doesn't exist, would be my point.
But to push back on that, like for identity in particular, if you want to verify identity on chain, you're doing some form of ZK KYC, you're going to need a verifier for that identity. Why can't you just deploy that contract on the other chain that you need to prove your identity on?
Because kind of identity is much more than kind of just, I mean, identity is also just an example here, right? So kind of I'll go into kind of the explanation for the identity example, but kind of happy to kind of give more examples too. So kind of an identity is in some way it's a collection of attestations, right? Kind of like what part of my identity kind of I prove to what application should be on me, and kind of depending on what I do, I might actually have to prove different things, right? Kind of like I might have to prove that I'm above 18. I might have to prove that I am a citizen of Germany. I might have to prove that I have more than XYZ amount in assets, so I'm an accredited investor. Whatever. I mean, there's different facets of your identity. And it's, to me, very identity is not a one size fits all topic.
Yeah, I get that, but
Guys,
I struggle to see a use case for sync composability outside of like cross-chain flash loans. Of just I used to work at a company that its whole point was trying to get synchronous composability adopted. Like anybody that's been on these calls for a few years can tell you that like I was very bullish on synchronous composability for a really long time. And now I'm working on protocol that's focused primarily on async. And I think in general, it's just the majority of synchronous composability use cases can be done with async atomic interop. And as more privacy preserving tech needs to be adopted in crypto, I think synchronous composability also gets harder and harder to adopt because doing anything at the sequencer level, I think, just becomes more and more difficult to get adopted for synchronous composability. Because I think in general, expecting like financial institutions to want to use a shared sequencer or like shared structures like that, I think they're just much more concerned on what does settlement actually mean here? What does finality actually mean here? And I think that in general, I think shared settlement solutions are more likely to get adopted for the long term compared to shared sequencing or synchronous composability solutions.
But I think we need to get off the table the shared sequencing part because that's really a 2 year ago kind of approach. We don't have that anymore. We do have solutions for kind of keeping sequencers intact. But I would want to say in terms of kind of the use cases, which kind of debate always comes about. There's a lot of things we're doing in Ethereum which enable new things to happen. Nobody's asking, no dApp is asking for faster finality. They don't care about it. But we still do that. No dApp is asking for post-quantum signatures. They don't really care about it, but we still do that. I think the thing here is that what is Ethereum exactly? If we require developers to redeploy their apps 30 times on different chains, I don't think this is kind of the vision of Ethereum we want, right? If users move between chains and moving between Ethereum and Solana and Ethereum and Base feels exactly the same thing from a UX point of view, I don't think this is Ethereum at all. And in terms of how urgent this is, I would put kind of this as kind of a point of reference, right? We're all kind of, a crypto trader is outraged with the tempo and arcs of the world, right? But I think we're missing a big question. Why did they decide, which are, both of them are really hardcore Ethereum projects at the beginning. Why did they decide to do an L1? There's two reasons I can think of. Number one is they want to control their infrastructure. But this is also true for the L2. They can still control their infrastructure. The second thing is, in my opinion, is that spinning up an L2 is as hard as spinning up an L1 today. Because when you spin out an L2, you need to recreate an entire ecosystem. You need to convince major dApps to redeploy their dApps. You need to convince solvers to connect to you, liquidity providers, and so on. And so it's not just about what exactly is the use case. It's also about the things it hinders. It hinders L2 advancements because it's very hard to spin up new L2s. And so for me, the urgency comes from not necessarily the things that dApp developers are asking or not asking today, is also from the things we as a community lose. The fact that Tempo and Arc are not an L2, in my opinion, is a really big loss for Ethereum. And in my opinion, if we would have had synchronous composability, the reasons for them to become an L1 would have been much harder to explain to the board of directors because the network effect of being part of Ethereum is so strong. And so that also goes back to the urgency part. I do think it's a philosophical and engineering question we need to ask ourselves. It's not just about who is asking what, because those things are not available right now. And so people don't even know how to ask for that.
Right.
I never liked the argument that we're enabling new programming paradigms, and that's why we should have synchronous composability. The only answer anyone can ever give me of why we really need synchronous composability is flash loans, and even that you can do asynchronously. Like the examples that you point out in this ETH research post, or people give, like needing to deploy the same dApps over and over again on chains, well, they probably shouldn't do that, right? you don't need a Uniswap on every single protocol if you're able to do cross-chain swaps well and cheaply, right? So not every L2 should be a copy of every other L2. You can start having like more specialized L2s. So I'm not throwing a big bone in this if we solve like synchronous composability in a way that scales, which is the real question. Most like no distributed computer system I know of in real life is synchronous. Like the internet didn't scale like that. No other network scaled to mass
But
while
but
being
but but
synchronous. So I think the real question is scale. The application can absolutely be developed asynchronously, and not every chain should be a copy of every other chain. Like you have deep liquidity chains like Arbitrum that it makes more sense to swap on than your random new L2.
But do
no,
you
so I
honestly
would
think, sorry,
I would say that almost every BFT protocol we have is at some point synchronous in times where it's kind of a happy flow and partially synchronous in other times. Synchronous composability does not require synchronicity between chains. They do not require the same block production, the same sequencer, or even matching up when block are produced or ZK proofs for those blocks are produced. We've moved past those points. We do have the research and kind of engineering behind to decouple those things and make it, in my opinion, scalable. But going back to the point of dApp developers, but that's the kind of the reality of the thing. DApp developers are redeploying their dApps a million times over, fragmenting their user base, bumping up their ops expenses and complexities. That's not because they want to. It's because for them, in order to touch individual domains, they have to redeploy their dApps because each chain is its own thing. They're not part of Ethereum. They settle on Ethereum, but they don't feel as part of Ethereum. And so I think that and also goes back to the question of how many rollups do we want, how much competition we want. I think it's not just about flash loans, it's about everything. Why do we need an interop vision where it's basically based on intermediaries and liquidity? That's it kind of goes against what Ethereum tries to be. Are we actually saying that the future of interop is solvers and liquidity for the top 4 or 5 tokens? What if I'm token number 50 on CMC or token number 100? Who will provide liquidity for me? So I'm not part of the L2 vision. I mean, it's very problematic. And again, I'm not dunking on anything. I think interop with intents is extremely important. There's things you cannot do with synchronous composability, but it's equally important to recognize that there's things you cannot do with intents.
like calling a smart contract from another smart contract on a different network.
Yeah.
I mean, if you look at the ways that dApps today interact on the same network, if they couldn't do that in the same block, I mean, you'd lose so much. So and I think kind of we're losing out on that in the wider Ethereum ecosystem between different L2s.
Well, you don't need synchrony for that. Like you can, of course, there's things that you can do with intents, and you can have asynchronous and arbitrarily fast down to real time composability and have all of that. And it's way easier to actually
Yeah,
build.
but so I would argue that a really really fast fasting is as complicated as synchronous composability without atomicity guarantees and without the bidirectional optionality of it, meaning that each step is its own thing. It's very hard to compose things when each step has its own latency, inclusion time, and so on and so forth. And so again, I think for me, it goes back to the question, are rollups part of Ethereum or their own chains? Really fast asynchronous composability is equally viable between Ethereum and Solana. So is there no difference between a rollup on Ethereum and Solana or any
It's very
other?
different. It's not equally
No,
viable because you
why
get
not?
trust minimized bridging between a rollup and Ethereum L1, whereas you stand no chance of having trust minimized bridging between a non-rollup and the L1.
Yeah, but if you're routing all of your messages through the L1 through Ethereum, you will have really high latency. And so you either choose real-time asynchronous message passing, which does not pass through the L1. And so you do have some trust assumptions, or you pass it through the L1, and then you have, for the very least, 12-second latency between messages today, or 6-second message latency in the future, hopefully when we shorten the slot times.
So if
You will,
you
you
have
will.
But it's you don't have long latency
RTT
though.
for an L2, you don't need to wait. Like it's
Sorry?
sync versus async is merely about the DevX. Like it's better DevX for synchrony, right? But if you are able to ZK prove an L2 in 6 seconds on average, you can go instantly. The L2 just needs to reorg together with the L1 to be able to have a view that's current into the L1. Like these are
Yeah,
orthogonal
but
questions. Let's not confuse the different dimensions.
no, but it's not exactly the same, because if you want to have ZK proofs, you need to settle them. It's not just enough to have a ZK proof of something, um, especially in the way rollups are built today. You have to settle them first in order to have that finality you want.
No. You
But I,
need to be able to create a proof that's gonna cost sufficiently little gas on the L1 that you'd be able
yeah,
to afford posting it on every block,
I agree,
every
but then
broadcast.
you're tying yourself with latency of the L1. And again, every
Yeah,
message
exactly.
is but that's a really big thing. Like if you need to every message to wait 6 seconds, it's really a lot of time. And that's thing number one. Thing number two is not a single contract today on Ethereum is built for asynchronous message passing. All of them are built for
Exactly. That's
synchronous
the big
composability.
advantage. Yes. That's the
And
strong
so,
suit of Symfony. Yeah.
yeah, but that's part of the single execution, right? For Ethereum, is Ethereum one big thing or not? And
Yeah.
so I'm not again. I'm not against asynchronous message passing. I think there's a lot of value to it in specific things. Interop is not one solution. As anything in life, you probably need a tiered system to solve interop. Um, but I think that it goes beyond what we're trying to focus here on use cases, flash loans, not flash loans. It's about DevX and UX. What exactly are the story we're telling for our users when they move between Arbitrum and Base? Are they moving between two different chains, or they're moving it between two domains within an Ethereum ecosystem? That's a really important philosophical question to ask, and I think that again, I'm going back to the example I gave before, Tempo and Arc. I think those are cautionary tales we need to take into consideration, because it's very hard to launch an L2, and so the difference between launching an L1 and an L2 is very minimal today. And the reason why is because there is no composability to speak of, in the sense that if I'm launching an L2, I'm alone, I'm an island, and it shouldn't be the case. And so it goes back to UX, DevX, L2 innovation and competitiveness, how contracts interact with other contracts. All of those things speak synchronous composability. Um, and I do urge everyone to kind of I know it's a lot of time, but synchronous composability came a really long way since 2 years ago, or even 1 year ago. And so not all of those assumptions are correct anymore. I think that we simplified a lot of different things, and we're continuing to simplify things. Even like the past week, we internally found a way to move assets without wrapping them. So, for example, moving USDC between rollups without wrapping it, using really interesting kind of liquidity provisions on a bunch of rollups. And because you have atomicity, you can do that. Without atomicity, you cannot. So things are improving all the time. Kind of my kind of thing that I wanted to kind of do is to make everyone aware of the advancements, and also allocate time and resources to continue developing it, because this, in my opinion, this is a really important component of future Ethereum we should kind of consider.
So we're running out of time here. I think this is a great discussion. I would love to continue it. Yeah, I think there's no question that this is worth more investment in exploration, discussion. I agree with Alon, your earlier point that Interop is almost certainly sort of a multi-tiered, or require a multi-tiered solution. There's not going to be a single thing that comes in as a silver bullet that magically solves Interop for Ethereum. Maybe, but I haven't seen it yet. And yes, to me, there's no question that we need to better, continue to explore things here. So I'm very grateful to have you and everyone else on this call that is pushing us in this direction. I think we should keep pushing here. And I think we need to maybe continue to better, at least from my perspective, better define the things that are really, truly only possible in this synchronous world. And it's like it goes into this sort of broader philosophical and prioritization. I think this is kind of where it starts to get a little bit messy of a conversation, but I would love to continue the conversation. So yeah, let's do it. Any other quick final thoughts? Otherwise, we can end it there. Awesome. Okay. Well, thanks so much. Thanks for the new people joining. And yeah, we'll see you all on the next call.
Thanks.
Thank you.
Bye, guys.
Bye.
Thank you, everyone.
Thank you. Bye bye.